Alright, my friends, we're almost at the end of this implementation. Congratulations again for implementing, part one that was quite big, technical, and then of course part two and part three to build and train our new artificial neural network, the CNN. And now we're going to tackle together part four to make a single prediction, which I remind will consist of predicting what's inside these two images. So this one and that one. So basically we will deploy our CNN on each of these single images and we'll hope that our CNN predicts a dog here and of course a cat here. All right, let's do this so you'll know how to basically deploy a CNN in production on a single observation. All right, so let's create a new code cell and we're going to start by importing NumPy. I should have actually left it as our essential libraries, that's what I mean. We always need NumPy, most of the time. So there we go, NumPy as NP, yes please. Please add this shortcut NP. Then we will import a new module, which is actually something we almost imported before, At the beginning we imported the image data generator from the image submodule of the preprocessing module of the Keras library. And in fact, what we would like to import now is that image module. But because we specifically imported something specific from that module, well, we need to import it again. So let's just do it quickly. So we're going to start from Keras, from which we're going to get access to the preprocessing module, perfect, from which we're going to import that image module. Great. All right, so now we have everything we need to make that single prediction. And now the next step will be, of course, to load that single image on which we want to deploy our model to predict if there is a cat or a dog inside. And therefore, I'm going to create here a new variable that will be exactly that image and which will be actually the input of the predict method. And we're going to call that variable test_image. As the image we want to test our model on in production. And the first thing we'll do with that variable, the way we're going to initialize it, is by simply loading it from our folder, our same single prediction folder that we have here. Okay, so the way we're going to do this is with a specific function of the image submodule, which is the load_img function, in which we can actually find right here by scrolling down a bit, or scrolling up actually. Where is it exactly? It is exactly here, load image function. So we're going to use that function to simply load an image into the PIL format. All right, so that's the first format we'll get, but you're going to see that we will need to adapt it a bit more to make it accepted by the predict method. Okay, so let's go back to our implementation and there we go. Let's call first that image submodule, from which we're going to call that load_img function. And inside this function, well, very simply, we have to enter two arguments. The first one is the path in quotes that starts from the root, which is, our dataset folder, and then going to that single prediction folder and then specifying which image we want to select. So we'll start with this one. And therefore, here we need to specify the path dataset/single prediction/cat or dog 1. All right, and that's exactly what is expected as the first argument of this load_img function. So let's do this. We have to enter it in quotes. So we start with the dataset, then slash, then we go into our single_prediction folder, and then we specify which image we want to select as this test image. Okay, and that's, let's just do a copy paste to make sure we don't make any mistake. So pressing enter, copy that, and then let's paste that back inside our implementation right here. All right, and this will lead us to that image, which will be that test image variable. And then let's not forget the extension .jpg. Okay, so that will lead us to that image so that this test image will become exactly that image selected. Okay, so that's for the first argument, and then let's add the second argument, a very, very important one, and actually compulsory. That image, which will become the input of the predict method, has to have the same size as the one that was used during the training. And remember, we actually resized our images into, this size, target size of 64 by 64, whether it was for the training set or the test set. And we specified this again when building the CNN right here with the input shape. So the size of any image we're going to work with, whether it is to train our CNN or to call the predict method, has to be 64 by 64. Okay? And in order to specify this here, we need to enter as this new argument, the compulsory one, target underscore size equals, and in some parentheses, 64 by 64. Okay, perfect. So now we have a first test image, but in order to be accepted by the predict method, which expects a certain format, we have to do some extra work here on that test image. And that first extra work is to convert that PIL format, which is a format of images, into an array. Remember that the predict method expects as its input a 2D array. You remember these double pair of square brackets which we used to input in the predict methods of our previous models, when predicting the outcome of a single observation? Well, here we're about to do exactly the same by converting this test image into an array. And the way we're going to do this is with another function of this image data preprocessing module, which is exactly this one, image to array, which converts indeed a PIL image instance into a NumPy array, which is exactly the format of array expected by the predict method. So we're going to use that function right away to convert our test image, which so far has the PIL format, into this NumPy array format. All right, so we're going to update our test image again. So I'm calling it again and then updating it by sending it equal to a new value. And well, as you understood, we're going to use our image submodule again, from which we're going to call this time the img underscore to underscore array function. And guess what it has to take as input? Well, very simply, it just needs to take that image in the PIL format, which we want to convert into the NumPy array format. And therefore, well, the input will simply be that test image and nothing else. We only need that image of which we want to convert the format. Okay, so that's the next step, but then we still have some extra work to do, which is still related to the fact that, the predict method has to be called on the exact same format that was used during the training. And well, remember that, when preprocessing our training set and our test set right here in part 1 data preprocessing, we actually created batches of images. Therefore, our CNN was not trained on single images, entering the network one after the other, but it was trained with batches of images. And therefore, we have this extra dimension corresponding to the batch. We have batch number 1 containing 32 images, then batch number 2 containing other 32 images, batch number 3, etc. So we have this extra dimension of the batch, and even if now we're about to deploy our model on a single image, well, that single image still has to be into a batch. Even if we're going to have one image in the batch, it needs to be into this batch so that the CNN model, and more specifically the predict method of the CNN model, can recognize the batch as that extra dimension. And so, you guessed it, what we're about to do now is just to add an extra dimension which will correspond to the batch and which will contain that image into a batch. And the way to do this is, once again, by, I just copied it before so I can just paste it. Once again, update our test image by adding to it this extra dimension corresponding to the batch. And the way to do this is with NumPy. That's how we can always easily manipulate a NumPy array now that, test image is indeed a NumPy array. And so I'm going to call NumPy first, which has a shortcut NP, from which I'm going to call this function, which allows exactly to add a fake dimension, or a dimension corresponding to the batch, and which is called the expand underscore dims function. And now you guess once again what we have to input inside this function. Well, we have to input the image to which we want to add this extra dimension corresponding to the batch. So first I have to paste once again our test image, but we have to add one extra argument here, which is where we want to add that extra dimension. And the dimension of the batch is actually always the first dimension, you know. That makes sense. You give first the batch of images, and then inside each batch, you get the different images. So it seems natural to have the batch as the first dimension. And to specify this, that's exactly what we need to enter here as this extra argument. And that parameter to specify this is axis, which we have to set equal to 0. Okay, so that the dimension of the batch, which we're adding to our image, will be the first dimension. Okay, and now we're getting very close to the final result, because now is the time we can call the predict method. Because indeed, that test image, which is not only in the right NumPy array, but also which has that extra dimension corresponding to the batch, has exactly the right format expected by the predict method. And therefore, here we can create a new variable, which we're going to call result, because it will actually be the prediction of our CNN called with our test image, but I'm not calling it prediction yet, because it will only return 0 or 1, and then we'll have to do some encoding work to say what is 0 and what is 1, you know. 0 will actually be cat and 1 will actually be dog. I'll explain why later, but there we go. We're just going to call this first result variable, which will be, of course, the output of the predict method called from our CNN. And so there we go. We need to take our CNN first, from which we're going to call, of course, the predict method, which will take as input, of course, well, our test image, which now has the right format expected by that predict method. So nothing else. We simply need to input test image here. And then now is the time to do that encoding work. So the way to figure out what is 0 and what is 1, you know, if 0 is cat or dog and 1 is cat or dog, well, the trick is to call the class indices attribute from our training set object. But since now we can't run this code, I'm just going to write the code that allows to know which indices correspond to which classes, and then you can see that on Jupyter Notebook. But I will just tell you that by using this, we actually know that 1 corresponds to dog and 0 corresponds to cat. So to get that information, we need to call our training set, or actually the test set as you want, and then from which we call this attribute called class underscore indices, just like that. And by printing this, you will get the right class indices. And with this, we indeed get that dog corresponds to 1 and cat corresponds to 0. And therefore, our final step here, you know, to have a nice result displayed in the output in the end, when we make that single prediction on these two single images, well, we're going to finish this with, you know, an if condition, where we're going to specify that if the result, all right, and now remember that result contains also actually the result into a batch, because it was called on a test image that was into a batch. So result also has this batch dimension. And therefore, we're going to first get access to the batch, and there are only one, and it has, of course, the index 0, because indexes in Python start from 0. So here we get access to the batch, and then inside the batch, we're going to get access to, well, the first and only element of the batch, which corresponds to the prediction of that same cat or dog 1 image, right? We're dealing with a single image, and therefore a single prediction. And to get that single prediction, well, we need to get inside this batch of index 0, well, the first and only element, you know, the first and only prediction, which has once again index 0. All right, so that's how we get exactly the prediction we want, by first accessing the batch and then accessing the single element of the batch. And that's exactly our prediction. And so if that prediction is equal, notice the double equal here, to 1, then since we know that 1 corresponds to dog, then we'll create a new variable which we're going to call prediction, and we'll set that prediction variable equal to dog. And then I'm going to copy this, because then in an else condition, you know, meaning if the result, you know, the prediction is equal to 0, then, well, prediction will be equal to cat. And then we simply finish this with a last code cell containing a simple print of the prediction. And that's it, my friends. This is how you make a single prediction with a convolutional neural network. So now it is the show time. It is time for the exciting step, because we're all going to sit comfortably in our chair and we're going to shoot this code on Jupyter Notebook.